My name is Chima, and today I'll be solving problem number 242, valid anagram. So let's get started. In this problem, we're given two strings, s and t, and we want to return true if t is an anagram of s and false otherwise. So what an anagram is that an anagram is a word that is formed by rearranging the letters of a different word or phrase using all the original letters exactly once. So in this example, we're given s equals anagram, t equals garam, and in this case, s is an anagram of t and t is an anagram of s. It's a bidirectional operation, an anagram is. Why? Because in s, we see all the characters here have the same frequency as in t, as well as the same exact type of characters. So in this case here, rat, we're given t as car, this is false because rat is not equivalent to car, right? In rat we have an R, and in car there's a C, and there's also a T here, and in the second string we have no T here, so we can't reform, S using the characters in T, or vice versa. So how do we solve this? So there's two things that we can extract from this question, right? The first thing is that for a string to be an anagram of another string, they both have to be of the same length, right? That's one thing. But the three things we can actually extract. So both are the same length. The second thing is they both have to each have the same exact characters uh, within both strings. And the third thing is that the frequency of each of the characters have to be the same, right? So three things: length, frequency of each character, and the uniqueness of each character. So let's solve that. So right off the bat, I could say if len s is not equal to len t, I can return false. Then to solve for the last two things, we have a very nice data structure called a hash map or a dictionary, where we can directly compare them to each other in Python and see if they're matching, right? So if two dictionaries are matching in Python, that means that the keys are the same. So the first thing that, like I mentioned, the uniqueness of each character are the same in both strings. Then the values are also the same. So the frequency of each character within both strings or both dictionaries are equivalent. So why don't we create a dictionary for both strings and then check if they're equivalent. If they're equivalent, then we know that S can be reformed using characters in T, and T can be reformed using characters in S. So I could say S dict equals that, T dict equals that. We could go for a car in S. S dict a car equals S dict gets car 0. This one. I'm going to do something very similar with T. Then all we need to do here is just return the equivalency of the dictionaries. Run that, see what happens. Test case is passed, let's submit it. And code is accepted. So let's go ahead and analyze the time and space complexity. So for this question, for the time complexity, we're doing two iterations through both strings, and we're just doing O of 1 operations here, just incrementing the values within our dictionary. So it's going to be O of n. For the space complexity, it's going to be O of n because we're using dictionaries. Dictionaries / map, and iterating through input. And that's it for this question.